Okay, so we are going to look at conservation of energy number 2. It is also exam 4, practice problem number 4. All right, the review problems. So it reads, an extreme skier, 65 kilograms, starting from rests, coasts down a frictionless peak that makes an angle of 25 degrees with the horizontal. The height of the peak is 4.39 meters. She coasts down the peak, starting at the top before coming to the edge of a cliff. Without slowing down, she skis off the cliff and lands downhill at a point whose vertical distance is 3.5 meters below the edge. How fast is she going just before she lands? So the key here is really identifying this picture. What does this situation look like? And admittedly, there is no picture there, so we are going to draw that for you. I'm going to draw that for you. So here's the peak. Here's my skier at the top of the peak. The peak makes an angle of 25 degrees, and its height is 4.39 meters. So the height of that peak is 4.39 meters, and then there's the cliff. So she skis down and goes off the cliff. That's what that description is supposed to represent. All right, so we want to know how fast is she going when she hits the bottom if the height of this cliff is 3.5 meters. Okay, so roughly 20 feet. How fast is she going? Well, I could talk about how fast she gets to the edge of this, and then what angle is she going off, and then do two-dimensional kinematics, and that would take the whole board. And we haven't even done two-dimensional kinematics. So there must be another way. Well, if she's moving, she's got some energy. And if she's at certain heights, she's got some energy. So let's look at energy. And remember that total energy at some point in the beginning has to equal the total energy at any other point. We'll call that the final. So the beginning of her motion we need to define. The beginning of the problem, what I care about, what's going to make solving for this velocity, that speed at the end, important. Not velocity, speed. Magnitude of the velocity. So let's start her at the top. So when she starts to go down, it says she starts from rest, and when she hits the ground. All right. So with any energy problem, because I'm looking at mechanical energy, potential and kinetic, I need to identify a 0 point. Let's identify our 0 point at the bottom. Okay, so I know that when she hits the ground, she has no potential energy. That'll make solving the problem a little bit easier. So let's go and look at our total energy. So I'm just going to rewrite the total energy relationship. And remind us that's the initial plus the kinetic at the initial condition. The potential plus the kinetic at the initial condition, and the potential plus the kinetic at the final condition, whatever it is. So at the top, what's my initial potential energy? My potential energy at the top. Well, it's mass times gravity times the height. Well, that's the total vertical height. So I have 3.5 meters and then another 4.39 meters. So I have 7.89 meters height, if my reference is the bottom, plus 1/2 m. What's my initial speed at the top? She's not moving. So 0 squared. And that has to equal my final potential, mg, well, she lands at the bottom, that's 0, plus 1/2 mv final squared. I don't know. In fact, that's what I want to know. That's nice. It's the only variable missing except m. Now, I'm given the skier's mass, so I could go ahead and plug 65 in for every one of those m's. Or I can remember some algebra tricks that let me say, all right, well, if I divide this side by m, I divide this side by m, I'm doing the same thing to both sides. The equality stays the same, and m gets canceled in all of these. So I can add the 65 in, but turns out I don't need it. So I end up with 9.8 times 7.89, that term 0, equals that term 0, 1/2 mv. Oh, no m. I just took it out to make life easier. V final squared. Then all I do is solve for V final. V final is equal to 12.4 meters per second. So it would have probably taken us about 20 minutes to do all the kinematics and thinking about the forces. Took me a lot less time. A lot more efficient, just as effective. So recognizing energy is happening, recognizing we can harness the power of energy, use energy, being careful and clever about what we set as our initial condition and our final condition, allowing those conditions to help me eliminate some terms, and using that conservation. Good job.